Hello, hello. Good morning, good evening, and good night. We are going to give everyone a few moments to trickle in. Welcome to the Cisco Nautobot SDN multi-domain, multi-controller, word salad webinar. So we'll get started in just a few moments while we let a few more people trickle in.
Give it another 60 seconds or so and we'll get started. All right, excellent. So first, I just want to start off by thanking everyone for joining today. Today's topic is going to be Nautobot plus Cisco SDN, multi-domain, multi-controller, unified inventory management. I'm going to go on to the next slide here. We'll start by reviewing the agenda. We'll start out with some introductions. We'll go into the challenges of multi-controller environments, introduce Nautobot and the Cisco SDN integrations, followed by a demo and a Q&A. Next slide, Jeremy. So for introductions, my name is Chris Murray. I'm a senior technical marketing engineer here at Network to Code, and presenting today is going to be Jeremy White. He's our principal developer advocate. Before we get into it, I do want to touch on our upcoming public Nautobot workshops. Don't forget to take down the code there if you're interested in joining, and you'll be able to get 20% off. And next slide. All right. And so before we kind of get into it, I just want to touch on what our solution does for companies. It provides a unified, holistic view of the environment and really addresses the challenges of controller sprawl. We think that once organizations adopt this approach, they'll find that it's much easier to manage these multi-controller environments. If you have questions during the presentation, feel free to ask them, but be sure to drop them in the Zoom Q&A as opposed to the chat. So with that said, I'll go ahead and pass it over to Jeremy.
Awesome. Thank you so much for the introduction. I will just go right back to one thing real quick. Make sure if I can be on the right slide. We have limited availability in some of these courses, so do make sure that if you would like to take advantage of this, to take down this course, screenshot this, make sure that you're able to take advantage of it so that if you want to sign up for it, you sign up for it soon before things fill up. And just to echo exactly what Chris just said, as we're going through today's presentation, if you have questions, feel free to drop them in the Q&A section. Don't drop them in the chat session, drop them in the Q&A session so everyone can be able to see them. We'll be doing our best to try and answer questions as we go throughout the content. And if we have time at the end after the demonstration, we will absolutely possibly be doing some verbal review and Q&A there as well. All right, so as our networks are changing and as we're moving from a single device management and we're logging in through CLI to moving into a controller-based solution, there's still problems that we're going to face. They're not going to be the same exact problems that we had in a single device management platform, but they're different problems. And we start trying to see what those are as our networks grow and as we start introducing our first second, and potentially third or fourth controller within our environment. And if we take Cisco as an example, we've got 4 great controllers that are available, and there's a lot more within the Cisco paradigm, but we're going to be focusing on these 4 today. We've got ACI, DNA Center, Meraki, and Viptela. They've all got a very robust API. They all have a very robust set of SDKs, very rich and intuitive user interfaces for interactions. But what we start seeing is that we have a different interface and a different UI UX, different set of APIs, different set of models for each platform. And this makes it to where as we're going in and we're configuring something in Meraki versus ACI versus Viptela, how we potentially configure that exact same item could be completely different. It could be updating an interface configuration, and the way we do it in Meraki is just fundamentally different in Viptela. They're different platforms. They're done differently. Even though we could still potentially have Catalyst devices under Meraki management, under DNA Center management, or under Viptela management. Same product line, but they potentially can be managed by different controllers and have that different management interface and different way of being able to achieve the same result. Each one, since they are completely different user interface and set of modeling and everything, it's going to have a learning curve. So that means that as we're onboarding new engineers, or as we are coming up to speed by just now introducing Viptela for SD-WAN, it's going to take a moment for us to understand and start realizing the value and what that user interface looks like, and how I'm actually able to make that interface update. And some of the biggest kind of caveats with all of this, looking at individual Bestowic controllers, they do phenomenally well in single domains. But as we start looking at interoperability and cross-platform visibility, we start kind of wanting more. So the controllers have given us a taste of what it's like to have a pane of glass into a domain. But what does it look like when we have multiple panes of glass for each domain? And can we abstract that to another layer and have that first pane of glass? And just kind of adding some additional flavor to these different UI UXs and how we manage and how we interact with them and what they're providing, it's going to be different. It's not saying that anyone does something wrong or does something bad. It's just that they're fundamentally different. They're solving different specific use cases in their respective domain. And that's okay. There's nothing wrong with that. That's absolutely what they're meant to do. But what if we can pull this up, like I said, to a higher level and make it a little bit easier for us to be able to understand where something might be? Especially as I start looking at some of those blurred lines that we're starting to see within our networks, especially when it comes to things like Cisco Catalyst, because Cisco Catalyst is now able to be managed underneath Meraki. And I think I technically have 2 icons that are swapped. But a Cisco Catalyst device could be under a Meraki dashboard management. It could be under a DNA Center. Or if we're using a Cat 8K, that could actually be our Viptela SD-WAN device. And so understanding that it's not going to be just as, it's not going to be like a Boolean value that is this device a Meraki platform? Cool, I go to the Meraki dashboard. It could be something that it's a platform or Catalyst that could fit multiple different buckets. And where do I go to get the status, to get the configuration, to update something for that very specific single Catalyst device? One Catalyst can technically start fitting into multiple different buckets. And let's say we start looking at ACI. We start looking at potentially having multiple data centers. Maybe we have a production and a lower environment that are separate ACI clusters. Maybe we had different business units or different control zones that have separate ACI clusters. Then it could be a game of, cool, I know this is going to be ACI, and I know that I'm in, let's say, the IADO 1 data center, but which ACI cluster am I on? is this production? Is this lowers? Is this DMZ? Do I potentially have to understand that I have more than one ACI cluster within one physical data center, and try and discern what specific cluster do I need to log into to be able to interact with the actual ACI nodes? And where this starts becoming more and more of a pain point, or more and more apparent, is as we start looking at a lot of our large enterprises over the years, we've gone through a series of mergers and acquisitions. Or potentially we are a company that is built where we have a tremendous amount of siloed business unit IT. And each either original company or each business unit has its own set of tooling, its own set of Meraki dashboard, Viptela, ACI, DNA Center, and so forth. And then as we are potentially either merging together or we're moving away from business unit IT into corporate IT, we now have to start looking at consolidation. And that initial consolidation is not necessarily meaning I'm going to get rid of one set of tools over another. That initial consolidation is absolutely going to be, I need visibility. I need an understanding. I need to know what's out there before I can make an informed decision on where I go next and how do I start working on consolidation. And this could be absolutely a dozen, 24, multiple different platforms that are all a controller managed solution that is managing thousands of devices within your network. It doesn't necessarily mean that it's just one ACI or two ACIs that are managing maybe a dozen spine leaves and the APICs involved with it. This could absolutely be a full branch site that has everything managed from the switching perspective through DNA Center. We have wireless through Meraki, then we have the SD-WAN for Viptela. And that could be multiple different flavors depending on the branch site, depending on the data center. And that's where we can start seeing that as we start looking at consolidation, either through business unit IT or through mergers and acquisitions, that we start having a proliferation of the same tools potentially, and trying to see what's that dividing line? What's that jumping off point to know, how do I know what control plane is managing that specific actual physical network device? Cool. So talked about, I've got multiple controllers. I've got specific platforms that could maybe fit into multiple different controller types, and the concepts of having business unit IT consolidating into corporate to a global or corporate IT, or mergers and acquisitions, or maybe I just have those 4 controllers plus maybe Panorama. Maybe I've got a few others that are out there. How do I still get that similar experience? I don't have to be a shop that's having to go through consolidation efforts. I could absolutely just be a shop that does Meraki for user base and ACI for the data center, but I want to be able to manage them in the same fashion. And that's where we come into play with the Cisco SDN manager. So within the Cisco SDN manager, it gives us the ability to use Nautobot as that first pane of glass. And so what I mean by that is that as we are working with and as we're interacting with our networks, we're going to need the ability to know what control plane to be able to automate against. So let's say we've got multiple ACIs and I'm implementing a change to potentially add a new set of leaves or potentially a port change. Doesn't necessarily matter what the change is, but I'm implementing a change and I need to know exactly what physical device is homed on which set of ACI controllers, what set of APICs. And that's where the Cisco SDN manager can give us that visibility to where I can see directly from an individual device, what is its control plane? And then from its control plane, I can then see what are the physical controllers that are deployed, if they exist, for that. And then I can start writing automation that has either via Nautobot jobs, through Ansible, doesn't necessarily matter, but has that direct correlation that if I mentioned a physical device for, like, let's say a leaf node in an ACI cluster as my inventory to update a port configuration, that physical device will have group vars or host vars, so have some metadata associated with it that'll have its connection details back to the set of ACI controllers or APICs. Same thing for Meraki or DNA or Viptela. And then that really brings in a tremendous amount of power, a tremendous amount of visibility for us to start using the data inside of Nautobot to drive automation most efficiently and have that same experience from domain A to domain B to domain C. And part of this as well is wanting to take the approach of understanding how can we start synchronizing that data? How can we start pulling in data into Nautobot to have that visibility? Because yeah, Jeremy, absolutely. I would love to have just throw all my devices into Nautobot, associate them to the controller. But then let's say my good buddy Chris Murray comes in behind me and cables up something else. And then he doesn't add that new leaf to the ACI cluster. Or let's say there's a project that we did a complete wireless refresh and no one ever went in and added all of the access points. Cool, I just spent days, weeks, hours, seconds, doesn't matter. But I spent time populating that data either through automation or manually. And then someone has come in behind me and has replaced the device, they have updated a device, or something has happened. Well, and that's where the Cisco SDN controllers comes into play. We have the ability to start leveraging the SSOT framework within Nautobot to start synchronizing data from our control plane directly into Nautobot itself. And actually, before I jump off to that, and that also makes it a lot easier at the same time that if we are needing to onboard and start generating and adding devices into our Nautobot instance, we're not having to manually populate those devices. We can leverage the SSOT framework, which I'll talk about a little bit more when I get to my demonstration, to be able to grab data from the controller, translate it into a common data model, and then update it on one side or the other. So we would be able to say, hey, here's my minimal set of parameters for my control plane. How do I connect into it? Then run the synchronization job, go grab my data. It grabs all the data from that specific controller, transforms it into that common data model, and then all of a sudden it's updated all of the devices into Nautobot to where that I now have that first pane of glass where I have that jumping off point and I have all of my data directly there. And we can absolutely rerun this SSOT job multiple times and update information. So as Chris wires up his new leaf node inside of the ACI cluster, I could then just say synchronize data, and it synchronizes the data from the ACI control plane into Nautobot, and now that new device is created in Nautobot. It's got its interfaces, it's got its IP addresses, it's got its association to the control plane, and everything is good for me to start working with there. So the key advantages of this is going to be from that first pane of glass, we have the simplified management. We have that same way of interacting with our devices, no matter if it is a ACI device or a vManage control plane or Meraki dashboard. It has that same UI UX, which means that we have a universal automated job execution for the way that we run updates or run changes can be exactly queried and performed in the same manner. To where that we're not having to know, cool, this Catalyst device is on Meraki, so I need to do the change this way through the Meraki dashboard, or this device is on DNA Center, I need to do it in this fashion. We can start creating that universal execution and universal change management possibility as well as now that I have all of this data in one source, it gives me the ability of having those linkages and having better visibility and control and understanding of where something may live and what is potentially controlling that device. And key point on Nautobot and any type of a source of truth is going to be that initial seed metric or that initial seed set of data to populate information into Nautobot itself. And via the SSOT framework and the what we'll be demonstrating in a moment, we have that automated capability to automatically populate all of that data directly into Nautobot and be able to use that data to action upon. And that can be absolutely treated as your centralized inventory. And it could be something to where that maybe we're not going through and doing direct changes in Nautobot. Maybe we are absolutely using a Ansible playbook, Nornier, maybe we're writing a fun little bash script. Doesn't necessarily matter, but we have that ability to have a centralized place to retrieve all network inventory for all automated tasks. And that doesn't mean that route switch is treated anything different from our network security versus data center clustering or whatever it might be. We had that single place for inventory for all networking devices. Even though we may have a manager or a control plane or a domain controller that is serving as a source of inventory for that domain, we have to know to go to that domain for that specific source of inventory. Whereas within Nautobot, we can centralize all of that into your first pane of glass when operating your network. So let's jump into some screenshots and let's kind of walk through a few things. And I'll do this actually live as well to kind of step through it. So the first portion that we introduced with this, because there's technically going to be two portions to this. We have the data modeling aspect, which gives us the ability to model out the control plane. And then we have the SSOT framework, which gives us the ability to synchronize the data. So as we were modeling out the control plane, we kind of took a step back and wanted to identify that the concept of a control plane doesn't necessarily have a one-to-one mapping to physical devices, clustering of devices, or potentially SaaS solutions. Like it's a little bit more fluid today than what it was 5 to 10 years ago or more. And understanding that from the control plane perspective, to a certain extent, all I really care about at this point is what is underneath control of that specific control plane. So what are those southbound devices? So what are the physical devices that are managed by the control plane? And what is my connection parameters to the physical, to the actual control plane? And what is northbound? And those northbound items are going to be the physical deployment, if there is one, of the actual controllers itself. So as we look at it, we'll see that we have within this view all of our controllers that are under management. So all the ones that we have within our Nautobot deployment, we have some basic sets of information that we would see for any type of normal Nautobot device. So we see a description, we see a status. We have the ability to have any manufacturer and any platform combination. So we can absolutely see we have all these integrations today built for Cisco, for Meraki, ACI, Viptela, and DNA Center, which is not on this screenshot, but is absolutely there. And then as we look at the type, one thing to kind of point out here is that we have 3 different representations of type. We have SaaS, kind of self-explanatory, software as a service. This is going to be our Meraki dashboard. So as we look at a physical controller deployment, there is not going to be a physical deployment. However, as we go a little bit down the list, we start seeing that we have our ACI cluster. And our ACI cluster is now labeled as an HA cluster dash, and then it's pointing to the FRA APIC cluster. This is actually pointing to a device redundancy group within Nautobot. And within the device redundancy group, you have the ability of modeling out what does that look like from an HA perspective. And then lastly, we have a single node. So maybe this, and although I do call it IADO2 ACI production, maybe this is a lower environment. Maybe this is a test or a mock production or some type of environment where we don't have multiple APICs within the cluster. Maybe we only have just one physical APIC. And then we can absolutely see every device that is underneath management control of that given control plane. As we start looking at the actual controller model, we can see that we have absolutely, like I said, the same bits of information that we would see with our normal Nautobot devices. We have manufacturer, platform, site. We can provide location data, tenant, comment, tags, and all of those normal bits and pieces that you're going to be familiar with within Nautobot. But we're going to see a couple additional items. We have controller type, which is either going to be SAS, HA, or single node. If it's HA or single node, it'll then also have a hyperlink to the actual deployment itself inside of Nautobot. We'll have a managed devices tab, which will be a list view of all the devices underneath management of this control plane. We'll then have our controller URL, which is going to be the link directly into the control plane itself. So I could just link directly from here into the control plane to log in. We have our secrets group. So this is what Nautobot can utilize to authenticate against that given control plane. So we are providing Nautobot the URL that we need to auth with, and we are providing Nautobot the specific credentials that Nautobot would need to auth with inside of any job. So as we're writing automation, if we're leveraging Nautobot, we are natively providing it exactly where to go to log in and what are your credentials to log in. And then some other kind of normal information that you would see for any type of API interactions. Now, the one thing that you may see here is this last sync attribute. This last sync attribute is actually going to be referencing the Nautobot SSOT. And so Nautobot SSOT, single source of truth, is to a certain extent, it's our opinionated implementation of an ETL framework, extract, transform, load. And behind the scenes, what it does is that we define a data source and we define a data target. And the process will go to the data source, grab all the information from the data source, extract it, transform it into a common data model. Then we'll go to the data target, extract the relevant information, transform it into that common data model. We'll perform the diff, and then we'll action upon that diff in the data target to update any information that we may need to update. And as long as we are leveraging the SSOT framework within controller models, we'll absolutely be able to see when is the last time I synchronized data in the SSOT framework for this given control plane, which is kind of really powerful to where we go back to that example of Chris being a wild cowboy on the network and plugging up a new Leaf device, but not putting it into Nautobot. Cool, I'm gonna go resync the controller. I'll have a timestamp on the controller the last time it synchronized. I'll have potentially a new LLDP information that's coming in through our monitoring solution, or maybe I've got an alert or a ticket or something that says, hey, this new device has been seen on the network and I don't see it in Nautobot. I can say, darn it, Chris, let me just go run the SSOT job, and then we're good to go. And then I can be able to see that, hey, the last time it ran was in June 15th. It's now June 28th. Let me just go ahead and update it real quick. On the Manage Devices tab, we're going to see our common device view. So we see device, site, device type, device role, platform status. And then we can also see that if we have any defined custom relationships, that the defined custom relationships get populated as well. Now, this is where it starts getting fun. So as we can see here, the IADO2 ACI production, which I think I swapped over to Frankfurt 02 or Frankfurt 01, is a controller type of HA cluster. So as I come here to the controller type of HA cluster, which, like I mentioned, was a device redundancy group, we'll see that the device redundancy group has a few more bits of information that wasn't there originally. So if a device redundancy group has a foreign key to a controller, we'll now see that we have a controller domain panel that shows up on this view, which has our link back to our actual controller objects, which is here. Has what our managed device count is. If we've been synchronizing it, we'll have that data here. And then we have our managed devices tab, just like we saw on the actual controller itself. And lastly, we are able to see the physical devices that are deployed as part of that device redundancy group. So understanding that some control planes are going to have a physical presence, and it could be a single device or it could be multiple devices that are participating in some form of a clustering as and providing that control plane management. Now, if we click through to a underlying device, we're going to see that we have the controller domain panel here. We'll see that it's managed by the Frankfurt 01 ACI production, which is going to be linking us back to our, to our controller view here, which I know I swapped between IAD and Frankfurt, but it'll link back directly here. And then I can click through on my controller URL to go directly to my control plane if I'm trying to understand where something may be located. All right, so let's jump into a demonstration real quick. Quick time check, looks like everything is good. Checking the chat and Q&A, no pending questions, so I'm good to continue. All right, so there's a couple things I'm going to point out here. So as we start looking at this, we're going to see within the DSIM panel, we have a new item that's here called controller, network device controllers. We'll also see it if we go underneath the devices menu, and we'll see controllers. They're going to be located here. As we pull up the controllers, we are going to see that we can start seeing the power of having all of this data co-located into one solution or your first pane of glass. To where you see, cool, I've got all of these control planes. I've got multiple different ACIs. I've got 2 separate instances of Viptela, 1 instance of DNA Center, 2 Merakis. I've got a couple different tenants, and I have a bunch of devices that are under management of a given controller. So let's go into, let's see. I'm going to go, actually, I've already got it pulled up, ACI 01. So ACI 01, this is absolutely going to be one of the ones that is going to be a multi-node control plane, meaning that it's HA cluster. It's going to be the multiple APICs participating in the cluster. So we can see we have our controller type of HA cluster, which links to the IAD01 APIC cluster, which I've already got that pulled up, and I'll nab to that in a second. We'll see that we've got our controller URL, our last synchronization time, which this has not synchronized. So I've got that to kind of understand and know that I'm not synchronizing that data. So this data has just been manually populated. And if I click on the Manage Devices tab, you'll see that I've got all of my devices that are underneath management of this specific control plane. So as I go through and I click on the APIC cluster itself, we can see that this is the device redundancy group within Nautobot, which is devices, device redundancy groups right here. And we can see that I've got my controller domain tab, which I link back to my ACI cluster. I've got the manage devices tab, which has now been injected into this core view. And I've got all of the physical devices that are participating in the HA cluster for this ACI instance. Now, I did mention that the controller type can be single node. And so as we look at that, we can go over to IAD02 ACI production, and we can see that the controller type is single node and it's pointing to APIC. And so if I open this in a new tab, APIC 1 is just a single physical device. So understanding that this specific deployment, it's just got one device. I've got my controller domain panel here, that's linking me back to my actual control plane, saying that this is a single node. The last time I synchronized my data was on June 15th, and I've got 4 devices underneath management, which if I click on the Manage Devices tab, I can absolutely see them there. And then lastly, as I click through to an individual device, I see that same controller domain item here, which I can very much just link directly back to my controller domain. And let's say that I wanted to go ahead and log into that specific controller domain. and I can very quickly and easily link through and connect to that specific device's control plane, to where I'm not having to try and figure out or understand what specific control plane, what is the URL, where do I go to log in to start managing that. So this has all very much been so far around the modeling side of things. This other portion is going to be, what does it look like from a Nautobot job perspective? So this is where the SSOT framework comes in. So as I mentioned, SSOT, single source of truth, is a Nautobot plugin or Nautobot framework that gives you the ability to extract, transform, and load data from two separate sources. And I see that, and actually I've got a question in the Q&A. I'm just going to do a verbal for the answer on this because I've got time. Is this a plugin for Nautobot or baked into the base version? What version of Nautobot is required? Great question. So we are absolutely going through the open source process at this moment. Thank you for reminding me of that. This has not been open source just yet. We are going to be deciding, are we going to initially open source the modeling portion as a separate plugin and the SSOT separately? Still finalizing those details. We should have a better clarity over the coming weeks. We are ready from the modeling side to start doing beta testing with some currently engaged clients. And after we are really kind of firm on that, yep, this data model is solving exactly what we're looking for, we'll be looking to open source it. As of right now, I believe if the initial beta might be coming out with a minimum of 1.5, but that is subject to change because it's not been open source just yet. The plan is absolutely to open source all of this work. If it's delayed, it might end up having a minimum version on the 2.x release train. So yes, absolutely, it's in the process. It may initially come out as a plugin, but the actual controller modeling, so just the data modeling portion, this is looking like this should be added into Nautobot and probably the 2.1 or the 2.2 release train. So this should be coming in as part of a core Nautobot model in the future, but we may start it initially as a plugin to get it out in the wild and get it in people's hands. And then later look at migrating it into core as part of Nautobot. Great question. Go back to jobs. Cool. Awesome. So as we're looking at the SSOT framework and looking at the Nautobot jobs, like I mentioned, extract, transform, load. We've defined how do we connect to the data sources on both sides, the source and the target. We define our modeling. We've defined what are those CRUD operations. We have the ability of selecting what specific platform that we care about, what is the tenant, and then what is the specific control plane. So if I was to not have tenant selected and I was to click on controllers, and I just have the platform, I will see both Merakis, but I only have under control of the managed airports tenant. And so I can click on run this job, which this will take about 2 minutes, maybe. It takes a moment. So I'll go back and I'll look at a previous execution of this. Take a look. And we can see that it goes through and it scrapes all the information from the data source, scrapes all the information from the data target, calculates our diffs, and then performs our CRUD operations. And as we look at our SSOT details, we can quickly see that on this specific run, that the side of MN01, I had devices AP01 and Firewall01, but it looks like their serial numbers changed. So this one, the serial last digit changed, and this one, it looks like maybe I populated it and fat fingered the serial number and didn't capitalize that last character. And it looks like also that I have a device that for some reason I never associated to the actual control plane itself. And we can go through and we can be able to see all of the synchronization logs and be able to see all of the information that's coming back from the SSOT framework. And so we can see specifically here on the update that, cool, this firewall 01 had a serial number update. And this is the exact change from that common data model. This representation is not the Meraki API implementation of the data. This is not the Nautobot implementation of the data. This is that common base data model within the SSOT framework. And that is what is actually performing the diff and giving us that visibility. And I'm sure by now that our job should more than likely be done. Just for grins, I'll go take a look. Everything completed. And because I had synchronized everything just before our webinar started, we can see that we have 0 created, 0 updated, and 0 deleted. And I think my caffeinated induced hilarity from talking so fast, I am actually ahead of schedule. Do we have anyone that has any additional questions that they would like to throw into chat that we could answer? Cool, got another great one. The title was Cisco SDN controller. I assume this is because the jobs are written for the SDN controllers. Would this be expandable to other makes and other vendors? Absolutely. So there's 2 portions of this. There is going to be the there is the modeling portion, and the modeling side of it is completely vendor agnostic. And it doesn't matter if it is a panorama device, if it is Juno's Mist or Apstra or CloudVision. It doesn't necessarily matter from that point of view. From the SSOT framework point of view, what has been developed so far is the ability to take data from one of those 4 Cisco controllers and pull it into Nautobot. What our long-term goals as well is to be able to take that data that we just pulled in and make Nautobot authoritative, so we can then use Nautobot to update information and push information back out. So the SSOT side, absolutely, that is very specific for what I'm showing today just on the Cisco side, but can be implemented on any controller itself. I keep referring to the SSOT framework. Is this a NTC thing or a published standard of some type? Great question. SSOT, as I mentioned, is single source of truth. That is our opinionated implementation of a ETL process, or extract, transform, and load. It is a plugin for Nautobot that gives you the ability to leverage a backend Python library called diffsync, which is where you create your underlying common data models, and then you create your adapters to connect to your data source and your data target. And if you wanted to take a look at that specifically, you should be able to go to GitHub. I could type. Nautobot plugin SSOT. So this is going to be your base framework. So on top of the base framework, we also have a few that are already published, which is in the process of changing just a little bit. But we have IP Fabric that is open source and published, vSphere, Infoblox, ServiceNow, CDP, and ACI. We are actually in the process of collapsing them into a larger monolithic repo to make it a little bit easier to manage and not have to say, hey, I've got 10 different controller types. I've got to install 10 different plugins. I should be able just to install one. So that's one thing that we're doing on the back end from an update perspective and is coming in. Martha, I see you've got your hand up. If you'll put your question into the Q&A section, I'll happily answer it for you. And I've got a question from about is sync unidirectional? What about automation using the SSOT to send data to the SDN controller? Absolutely. Right now, what has been developed is a unidirectional sync. So we have the ability to pull data in on these controllers from that remote data source into Nautobot to make Nautobot that first pane of glass. But we have the capability, and our long-term vision for this specific plugin and integration is to have bidirectional sync capabilities, so that we have the ability to initially onboard all of our devices into Nautobot. Then Nautobot becomes authoritative, and then as we make updates in Nautobot, we can then trigger the SSOT sync to push data out to the remote devices. And I've got 2 more questions kind of pertaining to the open source SSOT plugins, which I believe are kind of all coming together as kind of one larger question, talking about there is SSOT plugins for Infoblox, ServiceNow, etc. If we are collapsing them, would they still be a different pip package, or they would be one? The goal is to turn them all into one underlying Python package, so that we don't have to worry about doing a pip install SSOT Infoblox, pip install SSOT ACI or CVP. What we would do is it would be pip install Nautobot SSOT controllers, or whatever the package might be. Don't know it off the top of my head. And each underlying dependency would be a separate extra. And so if you look at it from the Python perspective, you pip install Nautobot SSOT bracket ACI bracket, or maybe it's pip install Nautobot SSOT bracket all bracket, and we get all of the controllers that are installed and all of their dependent packages as well. Great questions.
Well, thanks for running us through the solution, Jeremy. I think that if that's all the questions, we'll end by thanking everyone for joining. And if there's any questions after the fact, feel free to join our public Slack channel, networktocode.slack.com. Anything you'd like to add, Jeremy?
Nope, it's been a pleasure. It's been phenomenal to take the time to go through and build out this solution and kind of see what does that augmented interaction with our network look like, especially since, like I mentioned in the beginning, moving into a controller paradigm, it's solving some problems, but it doesn't necessarily solve all the problems. And this kind of really helps to bridge that gap in some of the initial pain points that you may see as you're moving into a controller-driven network environment.
Absolutely. Awesome, Jeremy. Thank you.
Awesome. Thank you, everyone.